Okay, this topic is conditional probability. So the example that we have here is we have a table where we have people in a town and we know their gender and we also know the color of their eyes, and it said everybody in this town is either brown-eyed or blue-eyed. So we're going to answer a bunch of different probability questions here. The first question is, if one person in this town is selected at random, what's the probability the person selected is a female? So let's see, how many females are there in this town? 5,132. And how many people are in the town completely? So we have 10,851 is that probability. What's the probability the person selected is female given that the person selected is blue-eyed? So this is what's a conditional probability. So what's the probability that they're female given that the person's eyes are blue? Well, now my denominator isn't going to be 10,851 because we're not looking at everybody in the town. We're only looking at the people in the town that have blue eyes, which is 530. And the question is, out of this 530, how many of them are female? So 71. And number 3, what's the probability that a person selected is brown-eyed? This is not conditional, so we just take a look at the entire total, 10,851. And out of those 10,851, how many of them have brown eyes? Right here, 10,321. And number 4, what's the probability that the person selected is brown-eyed given that the person selected is male? So here's my condition. What's the probability they have brown eyes given that they're male? So how many males are in this town? 5,719. And out of those males, how many of them have brown eyes? 5,260. Problem 5 is not conditional, it's just what's the probability they're male. Problem 6 is conditional given that. So what's the probability that they're male given that they have brown eyes? So let's see how many people in town have brown eyes. 10,321, and out of those people, how many of them are male? 5,260. 7 is not conditional probability. 8 is. It says given that. What's the probability that they're blue-eyed given that the person selected is female? So let's see, in this town there are 5,132 females, and out of those females, the ones with blue eyes is 71. Looking on the next page, let's take a look at these card problems. Here's our formula for conditional probability, and the formula for conditional probability is just the formula that we'd seen before rewritten. So before, if two events are dependent, probability of B times the probability of M given B would equal the probability of B and M. So it's the same formula we saw before, just rewritten to get this by itself. So the probability of M given B is the probability of B and M over the probability of B. Okay, so let's see. Here's our deck of 52 cards. Find each probability. The card is a heart given that an ace is drawn. The probability of heart given ace. Well, there's only 4 aces in the deck, so that's my denominator. And what's the probability that we find the heart or the ace of hearts? So there's only 1 ace of hearts, 1/4. What's the probability the card is the 6 of clubs given that a club is drawn? Well, how many different clubs are there? There are 13 clubs. And what's the probability we get the 6 of clubs? Well, there's only one way to get the 6 of clubs. What's the probability the card is a spade given that a black card is drawn? Well, half the deck is black, so if there's 52 cards, that's 26 of them. And out of those 26, 13 of them are spades, or half. Now we're talking about rolling a die. So what are my outcomes? I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So a 6-sided die is rolled. Find each probability. What's the probability you get a 4 given that it's an even number? Well, there's only 3 even numbers there, and there's only one way to get a 4, so 1/3. What's the probability of 2 is rolled given that the roll is less than 6? Well, there's 5 outcomes that are less than 6, and 2, there's only one way to get that 2, so 1/5. In number 6, an even number is rolled given that the roll is 3 or 4. Here there's only 2 different possible outcomes, and the only one that's even is the 4, so 1/2. In problem 7, we're going to make a Venn diagram for this. In a survey at a school cafeteria, 60% of the students like vanilla, 40% like chocolate, and 50% like both. So if we want to draw this diagram, because people like both, we're going to have the people who like vanilla, the people who like chocolate, and the people who like both is in here. So 15% like both. If 60% of the students like vanilla, but 15% of them are also in this chocolate group, then let's figure out how many of them just like the vanilla. So 60% minus 15% is 45%. And here we're told 40% like chocolate, but out of that 40%, some of them like vanilla as well. So let's subtract 15 from 40 to find out that 25% like just chocolate. So there's some students who were surveyed that didn't like vanilla or chocolate. Let's figure that out. So if I add these up, I get 85%, so subtracting that from 100, 15% didn't like either of those two. Okay, so what's the probability that this person liked chocolate, given that this person also likes vanilla? Well, if I want to, I can use my rule for calculating conditional probability, which would mean what's the probability of chocolate and vanilla, that they like both, given that they like vanilla. Here's the given that part. So let's see, what's that probability that they like vanilla? Well, 60% like vanilla, so this entire circle here. And how about what percent of them like both? So 15%, or that overlap, like both. So 0.15 divided by 0.6 is 1/4.